In lesson 3.3, we are solving logarithmic and exponential equations. So let's say we have a log in the equation. What you want to do is condense the logarithm and then either cancel your logs or rewrite the logarithmic equation as an exponential function so that you can solve for x. So first step was to condense. So on this side of the equation, they have matching logs and we're adding, which means we can use product property and put the 3 and the x together using multiplication. And if I have this side equals that side, and those things are the same, if they're equal, then the things inside the logs must also be the same. So anytime you have log equals log and the logs match, you can just cancel the logs, which is what we're saying here. Cancel them. So you have 3x equals 6 and divide by 3, you get 2. For b, there's nothing to condense, so we're going to rewrite the equation in exponential form. 5 to the third equals 2x plus 1. 5 to the third, 5 times 5 times 5 is 125. Subtract 1 to the other side, divide by your 2, and you get 62. Here, it's already log equals log, they match. So if both sides are equal and the logs are the same, then so are the things in the logs. So we set these equal. If I subtract x to the other side, I get 4x. If I add 1 to the other side, I get 9. And then divide by 4, 9/4. Here I've got, I can condense this side. So subtraction, I'm going to use quotient property of x divided by 4. And then here I've got log equals log. They match, so they cancel. So we can set x divided by 4 equal to 1/2. You can cross multiply, or you can think of this as multiplying both sides by 4. Half of 4 is 2. We can condense this side. The logs match, so we can use product property, log base 2 of 6 times x. And then we can get x out of the log by changing it into exponential form. So 2 to the third equals 6x. 2 to the third is 8. And when you divide by 6, you get 8 over 6, or 4/3. And then over here, we can bring that 2 on top, make it an exponent, which is condensing. And then your log equals log cancels. And to solve, you can take the square root, which gives you plus or minus 7. When you take a square root or you factor with logarithms, you have to be really careful because logs, you can't have negatives. And you also can't have 0. So you always want to make sure that your answers work. So positive 7 works, but negative 7, you can't take the log of negative 7. So really the answer is just positive 7, even though it would have been plus or minus. Over here, these are exponential functions, and we can use logarithms to help us. So step 1 would be to simplify, and step 2 would be to either write it as the same base, like we did the other day, or change it into logarithmic form. So this one, for example, we could change into the same base. So 4 and 8, we could get them down to the same base of 2. So 4 is 2 squared, and 8 is 2 cubed. And if the bases are the same, then their exponents have to be the same if they're equal. So this is going to be 6x if you multiply, and 3x plus 3 if you distribute. And if you subtract 3x to the other side, you get 3x. And if you divide by 3, you get 1. 4 and 15, there is no way to get those to be the same base. So we are going to change this into a logarithm. So change it into logarithmic form by doing log base 4 of 15 equals x. And some calculators won't do that. So what you'll do is change a base formula, and you'll do log base 10 of 15 divided by log base 10 of 4. And on the calculator, you get approximately 1.953. Over here, it looks like we can get the same base because 8 can be written as a base of 2. So 2 cubed is 8, but since it's on the bottom, it's a negative cube. And since the 2's match, you can set their exponents equal. So I have negative 3 equals 2x minus 8. Add 8 to the other side, and you get 5. Divide by 2, and you get 5 halves. Over here, simplify first. I can add 2 to the other side. And then to find x, I need to get rid of the e, so I can change it into logarithmic form. This would be log base e of 52 equals x. And remember, log base e is ln. So we can just type that right into the calculator. Natural log of 52, type that in. You should get approximately 3.951. Again, here we need to simplify first. We need to subtract 4 to the other side to start. And so you get 17. And then there's no way to get 10 and 17 to have a matching base, so we're going to change it into logarithmic form. Log base 10 of 17 equals 2x minus 3. Remember, log base 10 is what your calculator does. So we don't need the 10. It can be an invisible 10. So you can just type in log 17 into your calculator, and the calculator will give you 1.230 if you want to try that. And then from there, we just solve the equation. So we add 3 to the other side, and then we divide by 2. So we're getting approximately 2.115. Again, no way to get 7 and 27 to have the same base. So we're going to change this into log form. Log base 7 of 27 equals 5x plus 4. And this, you'll have to use change of base formula in your calculator. So we'll have log 27 divided by log 7 on the calculator. And when you do that, you should get approximately 1.694. And then from there, you will subtract 4 to the other side. And then from there, you'll divide by 5. It's approximately negative 0.461. And then over here, again, simplify first. So anytime you've got division or multiplication, addition or subtraction going on outside of the exponent, you need to take care of that first. So if there's a times 2 in front, you have to divide 2 to the other side first. You should have just the thing with the exponent isolated. This one, again, you can change into log form, or 81 can be written as a 3 with the same base. That is 3 to the 4th, and if the 3's match, you can set the exponents equal. So subtract 5, we get negative 1. So that is solving equations with logarithms. And now we're going to move on to word problems. So whenever we have compounded interest, you should have looked at this in Algebra 2. Anytime it's compounded continuously, we use the equation that I call PERT. Y equals P times E to the RT. Different books use different letters. I like PERT because I can remember it. And for me, this means Y is the end amount. if we're talking about money. P is the principal or the starting amount. E is the Euler number, so that's just 2.7 approximately. R is your rate, and we write that as a decimal. And then T is your time, and it's usually measured in years. So that's what the variables mean. And now we're going to use that to solve this problem in example 3. So we've got depositing $500 if we pick out our important information. It pays 6.75% interest. That's going to be a rate. Compounded continuously tells me to use PERT. And it asks the question, you always look for the question, how long will it take for your money to double? Okay, so we want our money to double. And they're asking how long. So we're looking for time. Time is what we don't know. So what do we know? We want money to double. So if we're starting with 500, that means we're looking for our money to be $1,000. Double what they said. So my end amount is going to be 1,000. My starting amount is going to be 500. So we've got the Y and the P. Now E is E. That's never going to change. R is your rate. And yes, it's written as a decimal, but it's written as a percent. And we don't want a percent. We want to get rid of that percent. So we're going to divide by 100 because it's 6.75% out of 100 possible. So we move that decimal point 2 places to the left to get rid of the percentage. So it's going to be 0.0675t. And we need to solve for t. So now this is just an equation again, like we did on the other page. And we need to isolate t. First, there's a 500, so we need to simplify this and get 500 to the other side. So if I divide both sides by 500, I end up getting 2. Which should make perfect sense because we wanted to double, and there's a 2 now. Now I want to get that stuff out of the exponent, so what we're going to do is change this into logarithmic form. So to be log base e of 2, remember log base e is ln. So you have ln of 2 equals 0.0675t. I just changed it into logarithmic form. And then log base 2 we can type into the calculator, and then we divide by this decimal. So what we're going to get is t is t is equal to ln of 2 divided by 0.0675. Ln of 2 divided by the rate. And when you type that into your calculator, you get approximately 10.269, which we're talking about time. How long will it take? A little over 10 years to double our money if these were the conditions of our account.